Hello friends, welcome to this tutorial of among the Pixlpal firmware series, where we'll be talking about the Pixlpal firmware architecture. Uh, the last tutorial we talked about the layout of the firmware, the various project files that make up the Pixlpal firmware. In this particular tutorial, we'll be talking about the various APIs that make up the firmware and how they interact with each other. As you can see on display, this is an overview of the Pixlpal firmware architecture. Uh, there are key parts which you can see in the various boxes and how they connect to each other using the directional arrows. Um, First, we have the user apps, which are the various applications that users interact with. Something noteworthy about the application is that every application you see here is a free RTOS task. And the advantage of free RTOS task, such tasks can be run, paused, or deleted. For instance, an application can be running for some reason you want it to be suspended temporarily. Using FreeRTOS gives you this ability. So each application is a standalone FreeRTOS task. When we go into the firmware code, you will see that being demonstrated. Equally, a particular application is run within the system engine. That's one application can run at a particular time. Though we have a feature where multiple apps can be selected and be made to run within specified time interval. They switch from one app to the other, enabling users monitor different app parameters as they switch or information, whichever the case. We equally have two categories of services, which is the system services as well as the shared app services. Starting off with the shared app services, uh, services themselves, you must know, are equally free RTOS tasks. It's just the configuration or the manner with which they run or are configured is a bit different from the applications. So the applications control the services, starting off with the shared app service. A particular application such as internet radio can make use of particular services here, not all. For instance, an internet radio needs to give audio output. So you can select, while configuring the internet radio application, you can include the audio out service. Upon initialization or startup of the internet radio app, this service will equally be called or started, and the internet radio will use this audio out service to give off audio output to your loudspeakers or headphones. You might equally have an application that doesn't need audio out but requires USB mass storage service. In that, while configuring that particular application, you can make use of the USB mass storage. A typical app, you can use multiple of these shared app service. For instance, button rotary encoder. For instance, the ChatGPT application makes use of audio out, audio in form of a microphone, as well as buttons and the rotary encoder for increasing and reducing the volume output of your audio out. So those are for the shared service. Now the system service are themselves free RTOS tasks, but these are used by the system while the application is running. The user or while configuring or designing the app, you can call this at will. That's this particular services. For instance, BLE communication between the mobile app and your Pixlpal app. You use the BLE comms services to exchange data or information. Your app might require the use of the buzzer, which is the piezoelectric buzzer embedded within the Pixlpal device, or make a particular update on the status bar of the Pixlpal. So these are not particular to any app. Rather, while the app is running, these shared or system services can be called or used. As was mentioned, they themselves are free RTOS tasks. Some run, they are completely independent of the applications. For the shared service, when the application is uh, deleted or changed from one to the other, the shared app services are themselves deleted and the memory they occupy are freed. When the next app is initialized, its own shared app services are themselves initialized. You can access this file in the GitHub repo for better understanding. We'll move on to the actual code implementation of applications and shared app services. So I'll take out this window and I'll bring in this. You can see on display the Pixlpal firmware code to navigate to this particular app, which is the internet radio app. You simply come to all open Pixlpal app and Metabits apps. Now, when users create apps which they wish to share, those apps will be placed among this directory, all open apps, so that other users can access or interact with such apps. That's other developers. So starting off with the internet radio app, I would show you how it's laid out. We'll touch on the Studio Lights app as well as the internet radio, which are contained within their own C++ file. Okay, let me give more room. Okay. So as was mentioned, each application is a FreeRTOS task, and this piece of code here, which we'll touch on later on, is used to describe the parameters for that particular app. For I believe listeners are familiar with FreeRTOS. So this describes the function that serves as the particular task, which will run in a loop, which can equally be found down here. So we use this particular API to register the parameters of that particular app. We'll touch on this when we describe the creation of apps in detail. You can see the app handler, which has already been declared at the top over here, task handle. Then the application name for debugging purposes, the application ID, as well as how much memory we wish to assign to this particular app or the task. These are all, of course, these are not the FreeRTOS APIs themselves, official APIs. However, these are wrappers around this particular line of code is a wrapper around the FreeRTOS API for creating new task. So this is the particular task function similar to your FreeRTOS task, and initialization happens within the very few set of lines of code. For instance, if you wish to have the rotary encoder or button functions, you use this API to register the particular function which will be used for button presses or encoder interaction, rotary encoder interaction. Equally, if the application will have Bluetooth communication between the mobile app and Pixlpal, the various functions that will perform this communication task are registered while the app initialization is being run within the Pixlpal at runtime. And as was mentioned, this is an example of a shared app, which is the audio out service that we mentioned. Let me bring this back. Audio out used by internet radio. At this point, the service is registered or initialized when the internet radio app task begins to run. I'll stop here. When we talk about the details for particular apps or creating apps, we would touch on more details on the various other initializations. The examples which I mentioned are more trimmed, they are more particular. Let me starting off with drawing shapes. So many initializations are not needed because this app is particularly tailored to demonstrate how to draw shapes to the Pixlpal device or on the Pixlpal device. I will return back to this, but to touch on still on services, I would move back to the internet radio example. And if you want to move straight to the implementation of a particular API or function or variable, you simply right click and go to definition on your Visual Studio Code. Similarly, in the same manner with which we declared the parameters of the application, same is done for the individual services. However, services don't have IDs but they have other parameters such as the amount of memory that particular task will occupy, the task handler, as well as the task description in form of text. As was mentioned, these are wrappers around the FreeRTOS API. So we have other services here that are particularly aimed at audio in, USB speaker out, USB speaker processing. And these are contained within the MTB audio or the metabit audio CPP file, which is a component on its own. I would lastly touch on the Studio Lights app, and you can see it follows similar pattern as the internet radio. It has the use of the rotary encoder and button, the use of function calls for Bluetooth communication. However, for this particular Studio Light app, you don't need any of the shared service. You don't need audio out. You don't need USB storage. So in that case, there's no point registering any service. As was mentioned, we'll go into details for creating applications as well as creating your own services. Lastly, if you can see, this particular app has multiple items running: the clock, the scrolling of text, as well as the GIF images being shown down here. I would open the app and you would see the app is called Pixel Art Clock, which is here. Pixel Art Clock. Okay, Pixel Anime Clock. It follows similar pattern, initialization pattern, focusing on the task itself. We have button, BLE communication, and we have a particular service. Now, this service is peculiar to this app alone. That is why this service is created within the app file or the app CPP file. And it's a FreeRTOS task under the hood with its own task. This particular task is used for drawing the images or cycling from one image to the other. I would go to the definition of this task, and you can see this is the content of this particular task, which is a service being used by this Pixel Anime Clock application. So we'll touch on how to create services that are peculiar to some particular apps, which may not be shared by other apps. That will be it for this tutorial. Thanks for listening. See you in the next tutorial.